First of all, very good evening to one and all. Uh, I'm Dr. Aakash. I have recently joined the Center of Biostatistics, and I would like to take this opportunity to thank the organization, especially Professor Pandey sir, to give me this opportunity to deliver this session amongst you all. So, during the given span of time, I would be sharing with you all the uh, insightful basic ingredients of statistics, which is really needed in systematic review and meta-analysis. Okay, and hope to have a very interactive and productive session ahead. Uh, yes, in fact, I can actually read your feelings right now. Okay, this is a post lunch session, and that too, I'm going to handle this session of statistics, and so I just want to make sure that uh, don't worry. Okay, so we will be making you feel very comfortable with all the basic things. Okay, so let's move forward with the session. Yes. Firstly, I would be talking something about the very basic, the descriptive statistics, okay, where I will be touching upon some, you would have heard over some time in your life, the mean, what is standard deviation, and then inferential statistics, you would have heard about some confidence interval, then p-value, then, standard error, some hypothesis testing. Then we would be stepping down into, yes, we have a different modeling approach when it comes to meta-analysis. That we will be talking some random effect model, we will touch upon fixed effect model, and then yes, if we have the actual extracted data, then we have to see, okay, what is the level of heterogeneity is present in our study, and we will be seeing all these things with different kind of statistical measure we have. I don't want to touch upon this at the very beginning, so step by step process we will go ahead and then we will see. Okay. Yes, and what it is, I try to club my two sessions in one session. In between, I would be, showing you some basic Excel function which is required. Okay, so yes, so what I could read since morning. Okay, you have done systematic. I mean, you have gone through all these sessions. Okay, you have extracted the data. You have done all these sessions from the morning. Okay, but when we start systematic review and meta-analysis, what is our feeling? Something like this. I think everybody can relate to me, right? And finally, when we complete, this is a successful completion. Okay, in between these two band, there are like many things that happen. Okay, so let's start with the very basic. I presume all of you know the what is mean. I need not to tell you. Okay, if I can tell you, okay, you if I give you the systolic blood pressure measurement of all the individuals sitting here, you can calculate the mean SBP. You can calculate the mean height. You can calculate the mean average. I mean, everything you can do. Okay, fine. Then talking about standard deviation, how many of you feel comfortable with the standard deviation amongst the audience? Okay, few of them feel comfortable. Okay, fine. So what it talks, basically it talks, it is a measure of dispersion. Okay, so how it talks about how much is all my values are deviated from my central value on an average. For example, standard deviation is 2. On an average, each unit is deviated from the center is 2 unit on an average. Okay, fine. And just you would have seen some time in life, when we talk about normal distribution, we have mean plus minus 1 standard deviation covers this much information, 68%, then double 95%, then 3 standard deviation covers some around 99.7%. Okay, yes, this confidence interval, for example, let me interpret this way. Yes, a study has been conducted to measure the average systolic blood pressure among hypertensive patients, and we have found the average is 140. The 95% CI came out to be 138 to 142. Now, what does that mean? Okay, it means 95% times, if you will, 100 times, if you will conduct the same study and try to have the average systolic blood pressure, 95% times your estimate of systolic blood pressure among hypertensive patient will lie between these two bands, that is 138 to 142. Only 5% is the probability that it might jump towards the right and towards the left of these two bands. Comfortable? Fine? Okay. So, it is given by, you can read this way, the estimate, what we are estimating, for example, mean plus minus, there is a confidence multiplier, that is, we know usual value is 1.96, that you can assume, and plus is into standard error. So confidence interval is given by the estimate plus minus confidence multiplier into standard error. Now what is this standard error? You understand everything, but you might be thinking, now what is this standard error now, right? So for example, standard error, I will tell you, the standard error of mean is given by, for example, what we say, s by root n, standard deviation by the sample size of under root n. But don't worry, don't worry. Let me first show you the standard error. What we told about standard deviation, the deviation of values from the mean on an average. That is the values. What we are estimating? We are estimating some statistic now. That is, we are calling mean. So for example, one study we have estimated average systolic blood pressure, that was 140. You have repeated the same study, you have estimated another average systolic blood pressure, for example 142. Similarly, for example, you have done 100 times estimation of this mean. You have how many means now? 100 mean you have. You calculate the mean of those 100 mean, which is equal to true, we call as true population mean. That is true mean. Now we are estimating, right, based on our sample that we took, we estimated some statistic, what we called mean. Okay. Now we want to make sure our estimate should be as good as possible. As good as possible means our estimate should be as precise as possible. As precise means we want to make sure our confidence interval of the estimate should be as narrow as possible. If the confidence interval of estimate will be wider, what you are trying to say, our estimate will be between these two bands. Okay. For example, the band is now 130 to 150. So somebody can estimate average systolic blood pressure as 131 and somebody can estimate 149 also, though there is a much difference in the estimation. Now you want to make it more narrow. Now you're telling my estimation interval could be 130 to 135, for example. Then what you did, you narrowed down the precision, you narrowed down the confidence interval, right? Fine. So standard error means that how much the sample mean is likely to vary from the true population mean. ठीक है? अब उसी जो we were having 100 means na, you have calculated the mean of those 100 means, you have got true population mean. Now you calculate the standard deviation of those 100 means, you will get the standard error. So standard error is nothing but the standard deviation of defined statistic. Now see, true mean is there, one estimate is there. What is your objective? You want to come much closer towards the truth. What is truth? True population mean. And your estimate, if it will be more closer towards the population mean, you are telling that I am much precise in my estimate. Could you relate to my this statement? Fine. Okay. So the standard error is for sample statistic and the standard deviation is for the sample values. Fine. In other words, it provides an indication of the precision of your sample estimate. So standard error of mean, for example, it is given by as by root n, where as is nothing but standard deviation upon sample size, under root of sample size. Fine. So you know the confidence interval is given by estimate plus minus 1.96 into standard error. Everything is depending upon this standard. So higher the standard error, the interval will be wider. Lesser the standard error, you can make the interval as narrower. Everything is depending upon standard error. So in our approach of meta-analysis, see what we will try to estimate. We will always try to estimate what we call effect size. I will come to that. Always we want to have the minimum standard error of that effect size, so that we could be more precise. You have to understand this. We could be more precise. Okay? Fine. So larger the samples, see, now standard error is inversely proportional to greater the sample size, lesser the standard error, confidence interval will be narrower, and that's what you are and that's what you're trying to do the justice to your study by getting the narrower confidence interval of your estimate. Fine. Okay. See, now I am going to take one scenario. Okay. For example, I am conducting one randomized controlled clinical trial among hypertensive patients. I have two groups. I want to make sure whether my intervention is effective in, for example, I have given one group to fibrate, one group placebo. I want to see whether my intervention is effective enough to bring down systolic blood pressure when compared to the placebo. So I have fibrate, I have placebo. For example, 100 patient I have. We can find out the average BP of SBP of 100, SBP of placebo of 100. Okay, something like this we will get. I want to see the effectiveness of my intervention, that is fibrate, is effective enough or not to bring down my systolic blood pressure when compared to placebo. Comfortable with the research question? Everybody is with me? Fine, good. So ultimately I have done this study. I have collected the sample, I have done the analysis, and now I am having this table in my hand. You can see the table. Fibrate is 130 with some standard deviation, placebo it is 1. A reduction of 10 unit of difference in the systolic blood pressure between fibrate and placebo is found to be statistically. The p-value generates evidence for effectiveness of intervention. Otherwise, you would have told the intervention is not effective. Is it fine? Now I am going to make in one statement. Please be with me. I'll come to you. Okay, and then I will try to seek answer from you. The difference of 10 units in the systolic blood pressure between the fibrate and placebo that we have observed is by chance, this probability is 0.03. What I'm trying to say? Not, I mean, I just want to listen some other language. In the way I'm saying, the difference of 10 unit that you have observed is by chance, its probability is 0.03. Again, I'm trying to repeat. The difference that I've observed is by chance. This probability is very, very less than what I'm trying to say. Exactly. It means it is not by chance. The actual difference exists, and that is why we are actually observing. When you say p-value less than 0.05, it is statistically significant, right?
It basically says that the possibility of it occurring by chance is 3%.
3%.
It means say significance level, you say.
Yes. For example, yes, please. Yeah. So what we are saying, it is by chance this probability is 0.03. It could be more less than that. It means what? For example, I am setting my significant level 5% and probability we have got 0.03. Then the difference that we have observed, by chance this probability is very very less. The other way around is the actual difference exists, means every time you do this kind of study, there the actual fibrate is effective, and that is why you are getting the difference of 10 units, for example 12 units, 15, it could be anything, but it is not happening by chance. It is the real difference that exists between these two groups, and that talks about the p value. Everybody is with me? Hands up. Okay, fine. So again, same. Some another RCT I have 10. Okay, I took the example of another RCT. For example, I have taken two group. I have asked one group to make the structured physical activity, and another group was control. I wanted to see whether if the structured physical activity is associated with glucose control or not. What I did, one group I have considered structured physical activity. Okay, one group I have considered structured physical activity. Out of 625 who did structured physical activity, 475% got their glucose controlled. Out of 625 who did not do physical activity, 40% got their glucose controlled. A difference of 36%. The probability of observing this difference is by chance is very very less, is less than 0.001. It means what? The structured physical activity is actually effective in controlling the glucose. So 36% difference that you've observed is not by chance, it is actually exist. Could you relate? Anything? Fine. Okay, fine. So now, yes, it is one of the most interesting yield of statistical analysis, because see, every clinical inference you draw, this is the guy who is the responsible. This is the guy who is responsible, right? Every clinical inference that you draw, it is based on the p-value. So that's why when it is one of the most interesting yield of the study, says probability that the difference at least as large as those found in the data would have occurred by chance. So if p-value less than 0.05, what you say? Probability of observing difference or association is purely by chance is so if the probability of observing p-value less than 0.05, what does it tell? The probability of observing difference or association is purely by chance is less than 5%. Okay? What does the converse means? 95% supports for the real or true association. Fine? Understood? Fine. So now coming to the, if p-value, now I am trying to relate to you all. If we get p-value, how do we feel? If we get p-value less than 0.05, how do we feel? Yeah, and that is what we were hunting for, right, since beginning of the study. Okay, yes, we feel very happy, we feel very, other way, We actually beg for it, right? We actually beg for it. Okay, fine. So now coming to the effect size in in the meta-analysis, basically when I said suddenly one word effect size in meta-analysis, so you might be wondering about it, what is this effect size now? The term effect size might be seen very fancy, but what is this? In a very lay person, I would like to explain. For example, the very previous example, the intervention of the the fibrate. Yes, in a very lay person term, if I would like to, make you feel comfortable with this effect size term. So the very first example that I would like to take, you were all with me in the example of fibrate and placebo one. We wanted to reduce systolic blood pressure. Okay. 1 rupee I have given. 1 rupee I have given. What is the difference that we observed? The difference was, it talks about actually what is the impact of your intervention. In other words, for example, if you say there is a 10 unit of difference that we have observed, okay, for example, it would have been 10-20 unit of difference. For example, it would have been 30 unit of difference. For example, it would have been 5 unit of difference. It could be, right? So what I'm trying to say, the effect of intervention, how much difference it can create between the two groups in the terms of average systolic blood pressure. If the difference is created, for example, high, we call it high effect size. Size of the effect, if it is moderate, we call moderate effect size. It is a small difference, low effect size. It is nothing but x1 bar minus x2 bar, means the difference in the two mean. It was 10, it could be 20, it could be 30, it could be 5. Larger the difference, larger is the, smaller is the difference, smaller is the, done, fine. Then we have standard mean difference. I will talk about it, don't worry. We can have odds ratio, we can have relative risk, we can have risk difference, we can have correlation, etc. We can have multiple effect sizes in the clinical research. This is what we actually pool in the meta-analysis. We always pool what? We pool depend upon the research question. For example, my research question was the way I took the RCT addressing reduction in the reduction among hypertensive patient in the systolic blood pressure. For example, the multiple studies that I would have done. What they will extract, you were extracting data, right? What you will extract, this group, mean with standard deviation. And then you will take difference of these two. You will tell mean difference, and that becomes your effect size. If it is binary data, for example, you will take odds ratio. Don't worry, I will come all of these odds ratio, relative risk, I will talk separately, okay? But I'm just trying to tell these could be the possible effect sizes: odds ratio, relative risk, mean difference. Now I will be saying standard mean difference. Don't worry, one by one we will talk about each and everything, okay? Mean difference, as I said, nothing but x1 bar minus x2 bar. There it was 10. 140 minus 130 was 10. Fine. Then we were having standard deviation also in both the group. If you remember the data, mean plus minus SD, mean plus minus SD. We always report mean with standard deviation. Anna? So once we have standard deviation, what we try to do is, if the standard deviation more or less same, then we try to pool these two pool these two standard deviation and want to work with one standard deviation. The pooling mechanism is very easy. We have the mechanism of pooling the effect size that is given by this one. What is that? N1 plus N2 by, I mean, you know, don't need any software for that. Trust me, you all have the mobile calculator. You can easily calculate all these things. What you need N1 plus N2, and you already know N1 and N2. You need S square pooled, right? What is S square pooled? N1 minus S1 square, N2 minus S2 square. I don't want to make you feel discomfort with the formula. This is very simple one. That's what I'm trying to say. And more often I'm just trying to say is we can work with the one standard deviation which are pooling with two standard deviation. We are trying to just make one standard deviation. Okay? And that is the way we pool it. Fine. We know S1 from this one study. We know S2 from the second study. Just transfer it. What is the problem? You will get one standard deviation. For example, see, and once you have the once you have the variance, see, this is the variance of what? Variance of effect size defined by the difference of mean. I told initially the standard error concept. हम क्या करना चाह रहे हैं? आप प्लीज इसको पहले थोड़ा ओरिएंट हो जाओ इससे, क्योंकि see, we are working with our estimate. Estimate could be anything. Here my estimate could be is a difference in mean. That there it was just single mean. ठीक है? अब हम क्या करना चाह रहे हैं? हम चाहते हैं कि estimate हमारा क्या हो? अच्छा हो, precise हो, standard error जो हो उस estimate का वो कम से कम हो, ताकि confidence interval भी कम से कम हो. This is fine. Everybody is with me? Fine. Now what we did is the formula for calculating the variance of difference in mean is given by something like this. N1 plus N2. Don't get too much worried about seeing the formula. I'm more oriented towards making you, comfortable with the conceptual frame what is working, I mean, in the background. Okay? So we have variance of difference in mean given by this. Now what is our objective? To have minimum variance. Variance जितना कम, क्योंकि standard error is nothing but the under root of that variance. तो variance जितना कम उतना कम standard error, और जितना कम standard error, I'm always stressing upon the variance of the estimate. You have to by heart it. Okay, variance of the effect size, we will be continuously working with that. So variance of the effect size, here effect size is difference in mean. So variance of the difference in mean is given by something like this. And once we got the variance, we just take the under root, we will get the standard error. For example, see, now we were having the x1 bar, x2 bar, we were having two standard deviation, we can pool it, we have pooled it, standard deviation formula say n1 minus 1 s1 square plus n2 minus 1 s2 square, pool kar liya, we have got one, we have got one, what we got? We have got the pooled standard deviation. Now what we want? Variance of the difference on mean. Already we know the formula, just transfer all these value and you got variance also. Once you got variance, you can take the under root of that, you will get standard error. Once you got standard error, what you do? You already know the difference in mean was 3 plus minus, I told you 1.96 into standard error of the effect size, which is 1.005. So in that way, what you did, you first evaluated the effect size, you calculated the variance of that effect size, you calculate the standard error of that effect size, and now you're reporting with, okay, the effect size, that is the difference in mean that we have, will lie between these two bands. Narrower the band, better is the estimate. Okay? Fine. Now see, now we are going, what we did, same thing, but we divided by the standard deviation. What does that mean? It means what we are trying to see, if the different studies reported the same outcome on different scale of measurement. It is not meaningful to compare or to take the raw mean difference. What we try to do here is we try to control the variability by dividing it by standard deviation. Now it is talking per unit standard deviation, what is the difference, so that all the effect measures across the studies will be comparable. पर यूनिट स्टैंडर्ड डेविएशन कितना डिफरेंस है हर स्टडी में, नाउ दैट इज कंपेरेबल. सो आई हैव स्टैंडर्डाइज्ड इट बाय डिवाइडिंग द बाय स्टैंडर्ड डेविएशन. नाउ इट इज अ स्टैंडर्डाइज्ड इंडेक्स. अगेन इट इज अनदर इफेक्ट साइज what we call standard mean difference. Nothing will change. Now also we will, what do we do? We will do variance इसका निकालेंगे, then we will find out the standard error of this one, and then we will construct the 95% CI. Somewhere you do in the forest plot meta-analysis, same thing I will be demonstrating in the subsequent slide. Okay, so by each and every, I mean, whatever the trying to deliver to you, each and everything is connected, and you will see in the subsequent slide, everything was connected, and that's how we have reached to this final layout. Okay, so everybody please pay attention and try to be with me, and if anybody has a question, please feel free to ask. Okay, fine. अब इसमें क्या किया, सेम पूल कर लिया. सेम पूलिंग आपको पता कैसे की जाती है, दिस वाज द फॉर्मूला, एंड देन वेरिएंस निकाला. इसमें वेरिएंस का फॉर्मूला थोड़ा सा शिफ्ट हो गया, ठीक है. वी आर नॉट वरीड अबाउट द फॉर्मूला एट ऑल. नो फॉर्मूला वी कैन गेट, नो वरी, बट व्हाट वी आर ट्राइंग टू गेट, वी आर ट्राइंग टू एस्टिमेट द वेरिएंस ऑफ the effect size. Here my effect size is standardized mean difference. Earlier my effect size was the raw mean difference. Now earlier बी वेरिएंस निकाला, यहां भी वेरिएंस निकाल रहे हैं. उसके पहले भी स्टैंडर्ड डेविएशन निकाला, यहां भी स्टैंडर्ड डेविएशन निकाल रहे हैं, स्टैंडर्ड एरर निकाल रहे हैं, जस्ट बाय टेकिंग द अंडर रूट ऑफ दैट. इज इट फाइन? ओके, सी दिस वाज गिवन बाय द साइंटिस्ट नेम वाज कोहेन्स डी. कोहेन्स डी ने ये सब कुछ दिया. देन ऑल ऑफ अ सडन देयर वाज अनदर साइंटिस्ट हु केम इन बिटवीन named HSD. He told, I will give you a correction factor which if you will incorporate, your standard error might get refined a bit. He told. Then he told you demonstrate. Then what he did, he take one correction factor defined by 3 by 4 degree of freedom minus 1. Now again you will tell what is degree of freedom now. Very simple. Suppose you have 10 observation, ठीक है? Suppose you have 10 observation and you have the mean of 10 observation, and if I will omit one observation, the 9th one, ठीक है? अब 9th वाले जो 10th ऑब्जर्वेशन मैंने रिमूव कर दिया, ठीक है? अब उस पे वही ऑब्जर्वेशन ऐसा कुछ रख गया कि आप एक मीन के बराबर आ जाए. मीन दिया हुआ है, 10 ऑब्जर्वेशन थी, एक ऑब्जर्वेशन लास्ट वाली हटा दी. अब मैं बोल रहा हूं इसी मीन के बराबर आनी चाहिए. तो यू हैव वन रेस्ट्रिक्शन, राइट और रॉन्ग? वी हैव वन रेस्ट्रिक्शन बिकॉज you will be putting only that figure. If you calculate the mean, it should be equal to the mean. So number of observation minus number of restriction is nothing but your degree of freedom. 10 observation कितना restriction था? 1. तो 10 minus 1 means 9 becomes your degree of freedom. ठीक है? Just you can realize that way. That degree of freedom is now 9. क्योंकि restriction कितना है? 1 है वहां पे. ठीक है? Fine. But again, don't worry about the degree of freedom and all. ठीक है? ये तो मैं बस बता रहा हूं आपको. What happened to this one? ठीक है? How much time do we have? हाँ? अभी तो कुछ पढ़ाया ही नहीं है. ठीक है? So this is given by J. I mean, see, again I'm telling you, this is just a correction factor. You do or you don't do, no problem. ठीक है? Just a demonstration. इसने बोला कि this is a correction factor, then you multiply the effect estimate, that is difference, standardized mean difference into this correction factor, your estimate will get refined. How? See, पहले क्या था, d एक्चुअल, ठीक है, वेरिएंस कितना था 0.0418. नाउ यू हैव गॉट स्टैंडर्ड एरर ऑफ 0.20, ठीक है. With hedges you are getting 0.2028, with cohens you are getting 0.2044. थर्ड और फोर्थ प्लेस पे केवल थोड़ा सा कम हो रहा है, ठीक है. So you do it, you don't do it, no problem, but conceptual frame will not change. What you would do, what you are doing, you are getting first effect size. Effect size could be raw mean difference, could be standard mean difference. Then what you are doing, you are calculating the variance of that effect size, right? You are calculating variance of that effect size, and then you are getting again standard error, and with standard error you will be building your confidence interval. Fine. Okay. Now I'll be talking something about odds ratio and relative risk. So, for example, see, I have two ways to do the study. First is, what I will do is, I will start with the group who is exposed with alcohol. The second group is non-exposed with alcohol. Follow data for some period of time, and then I will see how many of them develop the laryngeal cancer and how many of them did not develop the laryngeal cancer. Okay? So I'm interested to talk about these two. Out of A plus B, how many who were exposed with alcohol, how many developed the cases, and those who were not exposed, how many developed the cases. Now I'm changing the way I have conducted. Now I'm saying I will recruit first laryngeal cancer cases today and non-laryngeal cancer patient today. I will retrospectively go back. I will inquire whether you were exposed with alcohol or not. ठीक है. Same has been talked by Dr. Ayush some time back. ठीक है. The way we conduct decides the design of this study. In the first, when I am starting with the exposure and non-exposure, following it for the outcome becomes what study design? Cohort study. When I'm starting from the cases and the control, direction of inquiry is from outcome to exposure. Earlier it was exposure to outcome. Okay, so different study designs generate different effect sizes. The cohort study design generates relative risk. The case control study design generates nice. So yes, it is between always the categorical variable. Sometime yes, I was lucky enough to get this smoking monkey. Okay, for you. Okay, fine. So what I'm trying to tell, you can know now. I don't want to say. Fine. Now, looking back, comfortable? Okay. So this is the way you already showed this direction of inquiry from exposure to outcome. Here the direction of from outcome to exposure. Right? See, now let me make you more comfortable with the, when we tell odds ratio, relative risk, what do we mean by that? How many of you are comfortable with the odds ratio? Tell me. Odds ratio, relative risk? Very few, still very few. No problem. See, odds ratio is what? Being a very lay person, odds ratio is the ratio of two odds. इतना तुम समझ पा रहे हैं. Odds ratio is the ratio of two odds. What is the first odd? Odds of exposure among cases upon odds of exposure among control. Now what is this odds now? ठीक है? What is, how do we define odd, you know? How do we define odd? Probability of happening of an event upon probability of not happening of the same event. So for example, odds of any, for example, I have defined probability of getting a head on the coin is 0.50. Probability of not getting the head on the coin is, so odds of getting head on the coin toss is fine. Similarly, see, same I have kept the example. Okay? Odds of exposure among cases What is the probability that the people will be exposed with alcohol? A by A plus C. Probability that it will not be exposed to alcohol? 1 minus A by A plus C. A by A plus C is the probability of happening, not happening, 1 minus A by A plus C. सेम है ना, हैपनिंग नॉट हैपनिंग 1 माइनस, ठीक है. वो क्या होता है, आता है A by C, ठीक है. ये क्या है, ये देखो आप, A by A plus C upon 1 minus A by A plus C, which is getting, you will get A by C. Odds of exposure among cases. Similarly, odds of exposure among control, B by plus D upon 1 minus B by plus D, you will get B by D. You div one odds ratio, what? Odds ratio of exposure among odds ratio among odds of exposure among cases upon odds of exposure among control. You have both, you divide it and then you get, that's how you get AD by BC. Okay, that's how you get AD by BC. Fine. So
That is why it is called cross product.
yes, that's why you do this cross product AD BC, because A B C D directly you do AD BC is for understanding, very simple. AD by BC you can understand. Okay, so for example, I have taken one one example. So I think this study design is clear. Among the laryngeal cancer patients were 200 cancer patient, 200 control. Okay, among the cases, how many were exposed with alcohol? 160. Among the control, 90. We are interested in comparing 80% or 45%. So what I'm, see what I told, odds of exposure among cases. Odds of alcohol, odds of what is exposure? Odds of alcohol consumption among cancer cases, laryngeal cancer cases is 160 by 40. Odds of alcohol consumption among non-laryngeal cancer is 90 by B by D. And the ratio of these two now, odds ratio is, it is coming with some confidence interval, right? है ना? Now see, what is the interpretation now? What how you will interpret? The laryngeal cancer patient were consumed all, because cases already happened. You are started with the cases. So the laryngeal cancer patients were consuming 4.88 times higher alcohol, higher than without laryngeal cancer case patient. Make some sense? Okay, fine. Now how to get, see, I told you here also we will do the same thing. You will, here effect size is what? Odds ratio. We will be getting a variance of odds ratio, then we will be getting standard error of that, and then we will be building our confidence interval. Fine. See, so actually the variance of getting odds ratio is not really easy, but getting the variance of ln of OR, natural log of OR is easy. This is given by standard error of ln OR is this one. So variance of ln OR will be just square of this one. So 1 by A, you have 2 by 2, you do 1 by A plus 1 by C, you take under root, you will get standard error of ln OR. Once you got standard error, what you do? You have to build the 95% CI. So you have ln OR plus minus 1.96 into standard error. What we do is, we calculate everything, then we get back to our original scale by taking exponential of the figure. I will show you how. ये सेम स्टडी थी, हमारा OR कितना था? 4.88. हमने नेचुरल लॉग ले लिया 1.585. हमने स्टैंडर्ड एरर ऑफ ln OR निकाल लिया, हमारे पास टेबल थी, वी गॉट स्टैंडर्ड एरर दिस वन. स्टैंडर्ड एरर आ गया, 95% CI कंस्ट्रक्ट कर लिया, फॉर्मूला, नथिंग इज चेंजिंग, एवरीथिंग इज सेम, नथिंग इज चेंजिंग. ठीक है. नाउ वी हैव कंस्ट्रक्टेड confidence interval for ln of OR, not OR. To get this, we will use the exponential function in Excel. Bus exp of this, and you will get the confidence interval of OR. यहां पे क्या था, LNOR का एक्सपोनेंशियल लिया, बैक टू ओरिजिनल मैट्रिक OR पे चले गए, ठीक है. एंड दैट्स हाउ वी डू इन मेटा एनालिसिस. वी ट्राई टू गेट द वेरिएंस ऑफ द इफेक्ट साइज. हियर आवर इफेक्ट, we started with mean difference, then standard mean difference, now effect size is now OR. Every year we have calculated the variance of the effect size. Here also we have calculated the variance of the effect size and the confidence interval. Comfortable? अब see, I may time ज़्यादा हो गया ना, this got stretched a lot. Okay, I'll try to finish it off as soon as possible. So significance of odds ratio, we know, we always test the odds ratio of is equal to 1, means see, CI of OR, if it is if lower limit is greater than 1, ठीक है, it is if the interval contains 1, if it is does not contain 1, and if lower limit is greater than 1, we call it as a statistically significant, that we call significant risk factor. If the CI of OR is 0.5 to 0.9, means the upper limit is less than 1, it is statistically significant, and again it falls in risk factors, I mean protective factor. If it is in between 1 and CI for OR is between these two band, if 1 is contained in the confidence interval, it is OR is not statistically significant. ठीक है, fine. So if it is greater than 1, it is a risk, it is less than 1, it is a protective, if it is contained, not statistically significant. Fine. Yes, it is for categorical data used to quantify. We have quantified, no, there was association between the laryngeal cancer and the alcohol, but how much? You told 4.88 times. Quantified and gave the direction. Is a protective or a risk? It was a risk factor. Fine. Now cohort study design, इसमें भी हम कुछ ऐसे ही करते हैं. Incidence rate among exposed, upon incidence unexposed, we get relative risk, and see. Same interpretation, is equal to 1, greater than 1 is the risk, less than 1 is the protective, ठीक है. And see, does HIV infection increases the risk of developing TB among the population of drug users? This is one research question, ठीक है. So what we did, okay, exposure was HIV positive and HIV negative, followed it to see how many develop the TB and, ठीक है. See, so we are interested to compare these two figures. How many, I mean, the people who are infected with HIV, this much people develop the TB, the people who are not exposed with HIV, this much develop the TB, and then incidence rate we will be calculating by the 8 by 215, and incidence of TB among HIV 1 by 289, right? And we will get ratio of these two, we will get RR is equal to 11. Okay, so how will the HIV patient are having 11 times higher risk of developing TB when compared to HIV negative. ठीक है, अगर इसी स्टडी को केस कंट्रोल की तरह कर दूं मैं, मतलब अगर टीबी पेशेंट को ले लूं और नो टीबी पेशेंट को ले लूं और फिर उसमें से देखूं कितने लोग एक्सपोजर था एचआईवी का, कितने लोगों, और नॉन टीबी कितने लोगों को एचआईवी का एक्सपोजर था, then what I'm trying to do here is, see, everything is same, odds of exposure among cases upon odds of exposure among non-TB patient, right? And then we will try to define the odds ratio, we will get the same value. So in case of rare disease, it has been said the RR is equal to O, or rare disease means you can consider less than 10%. The prevalence of TB is around 3%, less than 3%, I would say. So the TB patient were 11 times more likely to be infected with HIV than non-TB subject. And similarly, you can see the RR equal to OR. I think we are running very out of time.
We can stop.
Yeah. So I think we can stop. Last one I would say. Okay. Then we can stop. Ultimately, we failed to touch upon the meta-analysis. Anyways, yeah. So this is one of the experiment where uh, there were two groups. One group was taking propanol, one group was taking nifedipine. Okay. Now I wanted to see how the people who consume the propanol, how many people have got reduction in chest pain. The people who were receiving the nifedipine, how many have got reduction in chest pain. So we are defining outcome as good outcome, right? Our outcome is good outcome. Just 2 minutes. Just this is a good. The way we are defined as a good reduction is good outcome. Okay. In this way, if you will calculate the incidence rate, you will be getting same thing. You will do, and you will get 4, which we will tell the relative risk of 4. You will say it is a risk, right? But it is not like so. Depend upon the way we are defining the outcome. Here it is the outcome is good outcome, reduction in chest pain. So the people, how do we interpret the reduction in chest pain among the subject in the propanol group was 4.08 times higher when compared to the patient in nifedipine group. Okay. I think I can take a pause. Huh? Okay. Thank you.
So it's very interesting session. Thank you, sir. Now I would like to request Dr. Lalisa to felicitate Dr. Aakash.
Very nice talk.
Thank you, sir. Ultimately, जो टच करना वो टच ही नहीं कर पाए.
Meta analysis और एक सेकंड इधर